Hi, everybody, and welcome to 10-3 Prediction Intervals and Variation. Our key objective. In this section, we introduce the prediction interval, which is an interval estimate of a predicted value of y. The prediction interval is the range of values used to estimate a variable. The confidence interval calculates the range using sample data for population parameters. The black line is the regression line. The confidence interval is small. We can be confident that the mean of a population parameter falls in a small area. For this example, median income in a neighborhood versus the predicted house value. If we're talking about one particular person, we can't take the mean of a person. We've got to give a much bigger interval because every person is different. Prediction intervals. The objective is to find a prediction interval, which is an interval estimate of a predicted value of y. Requirement. For each fixed value of x, the corresponding sample values of y are normally distributed about the regression line, and those normal distributions have the same variance. Procedure for constructing the prediction interval is the same as for finding the equation of the regression line. The results are displayed in the accompanying table. See the standard error of the estimate, S sub e, which is denoted by standard error. We are definitely not going to be using these formulas, but I did want to show you something on this slide. Given a fixed and known value of some x, we're going to plug x into our regression equation. Out is going to come some value of y. That is our y hat. Remember, we're estimating. The value of y got to be somewhere between the estimate plus the error and the estimate minus the error. For example, we have our chocolate and Nobel laureates finding a prediction interval. For the paired chocolate Nobel data previously used, we found that there is sufficient evidence to support the claim of a linear correlation between these two variables. The regression equation is y hat equals negative 3.37 plus 2.49x. We're going to go to StatCrunch. I already have StatCrunch open. Go to Stat, Regression, Simple Linear. Chocolate, Nobel. We want to find a prediction interval. We have a value. Remember, the prediction interval is a certain number being within a certain range. The prediction of y, my x value would be 10, because it says substitute x equal 10 into the regression equation. We're not going to do that. We're going to do it with StatCrunch. We always want to look at our graph. Notice down here, predicted values. That's a new thing that just showed up. Here it says predicted value of y hat is 21.5. We have 21.6. That's because we're using rounded numbers. It's going to be off by a little bit, don't worry. The 95% prediction interval could be manually calculated using these components and knowing what our standard error is. We don't need to do that because we have StatCrunch. I have my 95% prediction interval for the value. Here is my prediction interval. We have our simple linear regression results. This is our standard error. This is our y-intercept, and this is our slope of the regression line. The 95% prediction interval is 7.8 to 35.3, if we round to one decimal, and it contains the Nobel laureate rate. That is a wide range of values. The prediction interval will be much narrower And our estimated Nobel rate would be much better if we were using a much larger sample of data. We have a very large range here. A confidence interval is much smaller range. Our prediction interval, which is in blue, is always quite a bit larger than our confidence interval. The coefficient of determination is the portion of the variation in y that is explained by the regression line. It is computed as r squared equals the explained variation divided by the total variation. The value of r squared is the proportion of the variation in y that is explained by the linear relationship between x and y. For example, if we use 23 pair of chocolate and Nobel data, we find the linear correlation coefficient. We have r equals 0.801. Find the coefficient of determination, r squared. All we do is take this value, 0.801, square it, and we get this. Find the percentage of the total variation in y, Nobel rate, that can be explained by the linear correlation between variation, chocolate consumption, and Nobel rate. Since we know r, we also know r squared, but we're given r squared anyway. Because r squared is the proportion of total variation that can be explained, 64.2% of the total variation in the Nobel rate can be explained by chocolate consumption. And the other 35.8% cannot be explained by chocolate consumption. The other 35.8 must be explained by some other factors and or random variable. But common sense suggests that this is somewhat silly to seriously think that a country's rate of Nobel laureates is affected by the amount of chocolate consumed. The only thing new is the coefficient of determination. R squared gives us the amount of variation that we can account for. And 1 minus that number is going to be the amount that we cannot explain. The prediction interval has to do with one single value, and the confidence interval has to do with population parameters.